You know, whenever you plug an Ethernet cable into a switch, it just works, right? We all take it for granted, but what is actually happening in that split second of connection? Well, today we're going to pull back the curtain and take a look at the secret life of a network port.
So take a look at this. It's just a standard network switch, a wall of simple-looking ports. But behind every single one of them, a really complex, super high-speed negotiation takes place in the blink of an eye. Let's decode what that digital conversation is really all about. So here's our game plan for today. We're going to start by seeing why a port is more of an intelligent gatekeeper than just a plug. Then, we'll get into the rules of conversation. We're talking speed and duplex. After that, we'll explore the automatic handshake that makes everything so seamless, look at why an admin might need to take manual control, and finally, see the absolute chaos that happens when that harmony breaks down.
Okay, first things first. We need to get one thing straight. This little port isn't just a passive plug. Nope, it's an intelligent gatekeeper, and its whole personality really depends on the kind of device it's on.
Think of it this way. Every port has a default personality. A switch port, which is usually for your internal network, is basically just eager to connect. Right out of the box, its status is up, which means it's physically up and the protocol is up and ready to go. A router port, on the other hand, is a bit more cautious. It guards the perimeter. It starts off as administratively down, which means a network admin has to give it explicit permission to turn on. It's a really fundamental difference, and it's all about security and control.
Now, this is what the world looks like to a network administrator. This command, show interfaces status, is like a complete health report for every single port. We're going to zoom in on three really important columns here. Status, which tells you if it's connected, duplex, which tells you how it's talking, and speed, which tells you, well, how fast it's talking. These three things are the absolute heart of a good connection.
So let's break down those two fundamental rules that control every single conversation happening through these ports. We're talking, of course, about speed and duplex.
So what in the world is duplex? Well, the analogy is actually really simple. Think of half-duplex like a walkie-talkie. I talk, then I say over, and then you talk. We can't talk at the same time. Full duplex, though, that's like a modern phone call. We can both talk and listen at the exact same time, which, as you can imagine, is way more efficient. So why does that walkie-talkie method even exist? It's all to manage something called a collision domain. The best way to think about it is like a shared party line on an old phone system. If two people try to talk at the same time, their signals just collide and you can't understand anything. Half-duplex creates the rules of etiquette, forcing devices to take turns to make sure those data collisions don't happen.
And this right here shows a huge leap forward in networking. Old devices, called hubs, basically created one giant, chaotic collision domain. Every device plugged into it had to pretty much shout and just hope no one else was talking. Switches, on the other hand, are so much smarter. They give every single port its own private, dedicated line. This totally eliminates collisions and lets devices have those nice, efficient two-way conversations using full duplex.
The other half of the conversation is, of course, speed, and we've seen quite an evolution here. It all started with the original 10 megabits per second, then jumped to 100 megabits with fast Ethernet, and now the most common standard for pretty much any wired connection is a blazing fast 1000 megabits per second, or what we all know as gigabit Ethernet.
Okay, so if every single connection needs to agree on both a speed and a duplex setting, how does it happen instantly without you having to do a thing? Well, that brings us to the magic of the automatic handshake. This whole process is called autonegotiation. The instant you plug in that cable, the two devices on either end kick off this lightning-fast digital conversation. They're basically trying to figure out the absolute best and most efficient way that they can both talk to each other.
And the process is pretty simple. Each device just broadcasts a list of its skills. It's basically saying, hey, here's all the stuff I can do. The device on the other end listens, compares that list to its own list of skills, and then they agree to use the fastest, best mode that they both support. This is exactly why networking just works, most of the time. The default setting is auto for both speed and duplex.
But auto isn't always the perfect answer. You know, sometimes a network administrator has to step behind the curtain and actually take manual control of these settings.
So why would you ever do this? Well, sometimes, especially when you're connecting to older devices, or maybe you're trying to enforce a really strict network policy, auto just doesn't cut it. In those cases, an admin can go into the port's configuration and manually lock in the speed and duplex, which basically turns off that automatic handshake. And they don't have to do this one by one by one.
For efficiency, there's a powerful tool called the interface range command. It lets an admin apply the exact same settings to a whole bunch of ports all at once. It is a massive time saver.
Manual control is also an absolutely critical security tool. It's considered a best practice to disable any ports that aren't being used. An admin just types in the shutdown command, and you can see the port status changes to disabled. It's basically turned off, closing a potential backdoor for anyone who shouldn't be on the network.
But here's the thing. Forcing these settings manually can go wrong. Spectacularly wrong, in fact. It can create a massive, really hard-to-diagnose problem. And that brings us to our last and maybe most important section, the duplex mismatch.
So, what happens when you break that negotiation? What if you have one device that's yelling, "Hey, let's auto-negotiate," but the other device has been manually locked down and just isn't listening?
This right here is the mismatch trap. Let's say you manually set device A to 100 megabits, full duplex. Now device B over on the auto side can actually sense the electrical signal speed, so it correctly matches the 100 megabits. That part works. But the duplex negotiation, that never happened. So device B falls back to a safe default for that speed, which just so happens to be half duplex. And right there, you have a huge problem.
This is a total disaster for your network performance. You've got one side that thinks it can talk and listen at the same time, while the other side thinks it has to politely wait for silence before it can speak. The result is just a constant mess of collisions, errors, and data having to be resent over and over. To the user, the connection feels completely broken, or just agonizingly slow, even though the little green lights are on and the speed says everything's fine.
So while auto-negotiation is this amazing piece of engineering, the duplex mismatch is proof that understanding the fundamental rules of the conversation is still absolutely essential. And that leaves us with one final thought. As our networks get smarter and more automated every single day, will the need for this kind of manual control and the hidden dangers that come with it ever truly go away?